santri, perempuan banyak muda, anak banyak susah, jalan tutup mata, uang dan ringgit, anak tak heranlah, ente tutup mata, anak tentu jalan.
Mr. Worldwide to infinity.
Dinda jangan marah.
Abang jahat aku.
I want a big boy, give me a big.
Hi and Assalamualaikum. My name is Muhammad AIDIL bin Mat. My student ID is 2022910207. Today, I will going to present about introduction of hydraulic jump.
Oh my god! Wow!
So, what is hydraulic jump? Hydraulic jump basically is a phenomenon in hydraulic that is generally reported in open channel flow, such as rivers and spillways. When a high velocity liquid is discharged into a zone of lower velocity, the liquid surface rises abruptly. The strength of the jump depends on the Froude number of the flowing entering the jump. Froude number represents the influence of non-uniform flow velocity on open channel, where subcritical flow is obtained at Froude number which is greater than 1, where subcritical flow is shown at Froude number less than 1. The experiment is usually conducted in an open channel such as a flume, where water flows over a fixed bed. The flow rate is typically controlled by adjusting inflow rate or by using a weir or a sluice gate. The water depth, turbulence and other flow properties are then measured at various points along the channel, including the jump point. The data collected during the experiment is then analyzed to understand the physics of hydraulic jump and its effect on downstream erosion and sedimentation. The objective of the hydraulic jump experiment is, the first one, to determine the relationship between the flow rate, initial and final water depth, and jump length. The second one is to visualize the phenomena of hydraulic jump in a rectangular flume.
Hi, my name is FARAHANA BINTI ABDUL and my student number is 2022916961. So here we're going to show you the procedure of hydraulic jump. First of all, we need to switch on the main plug of the tank. Second, we go to the tank and switch on the tank and turn the valve on until there is a flow through the flume. Third, we have to measure trough, width, and measure Y1 diameter of blocker and YG. But from our project, we decide to use 0.8 cm for YG. Fifth, create a hydraulic jump in the trough by turning the pump on while put the stopper to the hole to prevent the flow out the tank and adjusting the flow control valve until the volume reach to 5 liter and the time is recorded. 6. After 5 liter of volume have been reached, measure Y2 and calculate V1 based on the flow and the cross-sectional area. Then remove the stopper so that the reading of a volume back to 0 liter. 7. Repeat steps 3 to 6 at a different flow rate by readjusting the flow control valve. Repeat the procedure until the data for a total of 3 flow rates have been recorded.
Now I would like to explain about the result that we obtain in the hydraulic jump laboratory. Okay, first we need to calculate the Froude number. So how to calculate Froude number? Basically, to calculate Froude number, we need to use this formula right here, and F is equal to V over set Gy, where is V is the velocity and Y is gravitational acceleration, Y is the height of the water before the jump. So after that, we need to calculate the ratio of the height of water after the jump to the height of water before the jump. Number 3, we need to plot the graph, where the graph is about the ratio between y2 over y1 versus float number. For number 4, we calculate the energy loss. We calculate energy loss by using formula E is equal to y plus v square over g. Then we need to compare the length of the hydraulic jump theoretical and the length of hydraulic jump experimental. Last but not least, we need to compare the ratio of y2 over y1 theoretical and y2 over y1 experimental. So as you can see here, this is our table that we use in the laboratory hydraulic jump. So here is the volume. We use volume of 5 meter cube, 5 to the power of -3 meter cube. Then we take the time for the volume to reach 5 from 0 for 3 times. First is 13.54 seconds, then 9.51, then 6.3. Then after that we calculate the y1, y2, the length of the hydraulic jump and the y0 before the third water gate. Before we forgot that we also need to constant the reopening YG, which is 0.004, and we need to measure the width of the flume, which is 0.075 meter. Then after that we need to construct a new table. The table consists of flow rate, y1, v1. v1 we find by using this formula, Q is equal to AV. Same goes to the flow rate. We need to find flow rate using V over T. Then we need to find float number by using this formula. Float number is equal to V over ZGY. After that, we need to find the ratio y2 over y1 theoretical. For experimental, we just use our experiment y2 and our experiment y1, divided it easily. We can get 7.0, 8.6 and 10.9. For theoretical, we need to use this formula. y2 over y1 is equal to 1/2 times z1 plus 8 times float number square minus 1. Then we need to find the length of the hydraulic jump experimental. Experimental, easily we measure it in the lab. For theoretical, we need to use formula. Is L is equal to 9.5 times y1 times float number minus 1 to the power of 1.01. Then we need to construct another table, the last table, table 3, that consists of flow rate, y1, v1, energy loss E1, y2, v2, energy loss 2, and the total energy loss. E1 is basically the energy before the jump, E2 is energy after the jump, eta E is energy loss. Then after that we finish our table. We need to construct this graph. So basically, as you can see here, this blue line here indicate that the experimental value for y2 over y1, and the theoretical value is indicated by using this orange line. So that's all for now. Thank you.
For the discussion part, me, ATISYAH binti Muhammad ROSLAN, metric number 2022996641, and my partner, Muhammad Faris bin Muhammad Zukiman, metric number 2022764321, will explain about it. The sluice kit employed or the use of area was used to manage the volume and maintain it steady during the experiment. At various points along the channel, including the jump point, the water depth, turbulence, and other flow characteristics are measured. To assure understanding of the physics idea of the hydraulic lift and its impact on downstream erosion and sedimentation, the data have been evaluated throughout the experiment. The data can be calculated by utilizing a flume with a width of 0.075 meter and a wheel opening of 0.004 meter. As shown in Table 1, the time decreases from 13.54 seconds to 9.51 seconds to 6.30 seconds as a result of the lab experiment, which gave us the constant volume of 5 times 10 to the power of 3 meter cube. Y1 has values of 5, 4.2 times 10 to the power of 3 meter cube and 3.4 times 10 to the power of 3 meter cube, while Y2 has values of 0.035 meter, 0.036 meter and 0.037 meter. We must determine the relationship between the Froude number and the ratio of Y2 divided by Y1 in the following part. The wave-making resistance between bodies of various sizes and shapes is compared using the Froude number. Whether a free surface flow is supercritical or subcritical depends on the Froude number, which might be more or less than unity. By measuring the trough width and taking measurements for the blockers diameter, YG and Y1 and Y2, we opted to utilize YG as 0.8 cm for the project. The flow rate for the first one is 0.37 meter cube per second, the second is 0.53 meter cube per second, and the last value is 0.79 meter cube per second according to result in Table 2. The L experimental and theoretical have very little in common. The theoretical value is 0.17 meter, 0.30 meter and 0.54 meter, but the experimental value is 0.39 meter, 0.46 meter and 0.54 meter. The table's Froude numbers are 4.38, 8.28 and 16.97. For the next discussion, I will pass it to my partner.
Our goal in the last part of this study is to identify energy losses based on the information in the Tables 3 data. The second part's value for the flow rate Y1 and Y2 is the same. We discovered that V1, E1, V2 and E2 using the provided formula. V1 values are 0.97 meter over second, 1.68 meter over second and 3.10 meter over second, whereas V2 values are 0.14 meter over second, 0.20 meter over second and 0.28 meter over second. The values of V differ significantly from one another. To determine the value of E, move on to the following. While the E2 values are all the same at 0.04, the E1 values are 0.05 meter, 0.15 meter and 0.4 meter. After all the value is calculated, the difference between the E can also be accomplished, which are 0.01, 0.11 and 0.45. Although the momentum is conserved throughout the hydraulic jump, the energy is not. There is an initial loss of energy when the flow jumps from supercritical to subcritical depth. The resulting loss of energy is equal to the change in specific energy across the jump pen is given by the equation of delta EB above. Regarding open channel flume, the impact of shear force may owe to the friction between hydraulic jump flow and wall sides. The hydraulic jump is used to dissipate large quantities of energy. The reason for this energy dissipation is due to some factors to decelerate the excess kinetic energy of the liquid so it will not damage the structure of the dam and causing failures. Hydraulic jumps are ideal for the mixing of chemicals for water purifications and treatment plants purposes. In this experiment, all the electric terminals were tightly connected to avoid partial contact. To avoid the parallax error, when taking the data readings, we were carefully and fully focused when conducting the project.
In conclusion, hydraulic jump experiments are an important tool for understanding the physics of the hydraulic jump phenomenon, which occurs when a liquid such as water flows over a fixed bed. The result of the experiment can teach students about how hydraulic jump occurs. and the knowledge from the experiment can be used to design more efficient and effective hydraulic structures, such as spillways and weirs, and to be understand and manage important environmental flows in natural channel and rivers. Thank you.
Get Smart, brought to you by